So let me actually share the screen with you now. So the last time we talked, we got into the beginning of inverse functions. And really, it was like what undoes a function and takes us back to x is what created the inverse, right? It was almost like an identity on x. And we talked about informally doing it, where we did a few where we kind of we would look at what was being done to the original function and thought about, well, how would it go back to x? And we could look at it and we could go, well, if I had f of x equals x plus 4, we could look at it and go, well, the inverse would be minus 4, right? Because that's what would take us back to x. And we could just look at it and go, okay, well, f inverse of x would have to be x minus 4. Or we had f of x equals 4x. And to get the 4 off, we would have to divide by 4. And we could look at it and go that f inverse of x would equal x divided by 4. And those are really simple, and there was nothing algebraic about them. But we talked about that, and then we talked about, well, how would we verify that these are actually the functions? And what we would do is we would plug f inverse in for x on the f function, and if it brought us x, then we verified it, right? And the opposite as well, we would plug f of x into f inverse of x. And if it gave us x, it would be verified. Do you guys remember that? Does anybody remember that besides Jameson over there? Do any of you that I'm just looking at pictures of remember that? All right. Today we're going to talk a little bit about their graphs. But you won't have to do a ton of graphing. I believe all of the homework problems that I gave you have you finding the inverse, right? Which we'll do in a few minutes. We will talk about how to algebraically find the inverse. But it'll just ask you which one is the graph of f of x and its inverse. And the main thing to remember when we're talking about the graphs of inverse functions, see, I don't even like the way this writes. It's all like, it's a little too fluid for me. I think I just have to get used to it. And the one thing to remember about this, let's hope I can still bring my picture up. There's my photo library. I don't even know where my library is anymore. Let's try that. Nope. Normally, I don't know where my little picture of a graph is that I always put in there. No, that's going to break my heart. No. Pictures? No. Camera roll, maybe? Ugh, this is killing me. This is killing me. I'll just draw a graph for right now. Right? I have to figure that one out, though. That's going to drive me insane. So if I have a graph, see, because my drawing of a graph is always going to be worse, right? If I have a graph of a function, it is always going to be symmetric about what we call y equals, oh, that's a terrible, it's all supposed to go through the origin there. That's a little better. So this line right here is what it would be symmetric around. What does that mean? Wow, it erased that entire line. This is y equals x. And what it's saying is that if I have, well, let's look at what we had here. We had x plus 4, right? If I had an f of x plus, if I had my f of x equals x plus 4, right? And I plug this in and I have x and y, and I could put in anything I want for x. I can go like -2, -1, 0, 1, 2. I always like to use those numbers because it gives me some negative, it gives me 0, and it gives me a couple positives so I can see the trend. And if I plug -2 into here, -2 plus 4 is 2, -1 plus 4 is 3, 0 plus 4 is 4, 1 plus 4 is 5, 2 plus 4 is 6, right? And I could plot all of these points on the graph, right? Saying, okay, I have a point at -2, 2, right? Let's call that 1, 2, right? And I have a point at -1, 3, and I have a point at 0, 4, and I have a point at 1, 5, right? Each time we're going a little bit higher. Then I have a point at 2, 6, a little bit higher, right? And I could plot the points of this line, right? Very easy to do. I can also plot the points of x minus 4, right? Our inverse on this one we said was x minus 4, not x minus y, x minus 4. And we can plot those points as well, right? Well, when we plot those points, if this is the inverse, these x and y values just switch, right? So this being the inverse, I don't even really need to plot the points. If I plug in 2 and I have -4, I'm going to get -2, right? If I plug in 3 for x and I get 3 minus 4, well, that's -1. 4 minus 4 is 0. Notice that our x and y's just switch. So on my new graph, this new graph that I've got here, and I plug in these points at 1, 2. Let's do 1, 2, right? At 2, -2, I would have a point. At 3, -1, I would have a point. At 4, 0, I've got a point. At 5, 1, I've got a point. At 2, 6, I've, at 6, 2, sorry, not 2, 6.
Wait, so for the second one where it was 1, -3, it's now 3, -1?
Exactly. Right? And if you notice, these, if drawn correctly, and in this case, they aren't drawn super great, right? Because I didn't have my thing. But what you would see is that this line, they're a mirror image on each side of that line, right? That y equals x, they are a mirror image of. So if I folded the piece of paper in half along this center line, I'm like trying to do it on the desk instead of my tablet. If I folded the paper in half along this line, those two lines would line up with each other because they're a mirror image of each other. They are symmetric about the origin, right? That means when y equals x, so if y is 1, x is 1. If y is 2, x is 2. They go along that diagonal on the graph. Every single graph of an inverse will be symmetric about that. Yeah, that's the best thing I have to say about graphing of them. I'm not making you graph a bunch of these. Even in your homework, I don't think you have to graph a single one. You might have to pick out the graph that is the graph of the function and its inverse. But what you just have to know about that is that they're symmetric, right? their x, y values are opposites of each other. So if you have one that has these x, y values, its inverse one is going to have the opposite, right? The x, y values on this inverse one is going to be 2, -2, 3, -1, nothing. It's all like, I hate this new thing. Like it's got an arrow thing that I need to go away. I don't know. Let's try that. 2, -2, 3, -1, 4, 0, 5, 1, 6, 2 would be accurate points in the inverse, right? Their x, y values swap. And we talked about that last week when we discussed the definition of an inverse function. We said that the domain or the inputs of the original function of f become the range or the y values of the inverse. And the range of the original function f, right, or y values become the x values of the inverse. And I know that that was super, super wordy. I get that and I apologize for it. But it was important, right? You need to be able to look at a graph and understand if something is an inverse or isn't an inverse. The only other thing graphically we're going to talk about is what we call the horizontal line test. The horizontal line test. Horizontal line test. When we're talking about functions, originally we talked about the vertical line test. And we said that if it's a function, you can drop a line vertically anywhere on the graph of that function, and it'll only cross at one point. The horizontal line test says if you draw a line horizontally, I always think of horizontal as the horizon, right? You can see the sun on the horizon, so it goes this way. Skateboarding, vertical. If you draw a line horizontally through the graph of a function, would help if I actually wrote these down because it might get wordy because I'm just saying it in my head. Through the graph of a function, and it only, not only, only crosses one point on the graph, then that function has an inverse. So think about that. If I have a graph of a function, say, let's do cubic, right? I can draw a graph through this. For some reason, it wants to give me a little arrow I don't want. Oh, I can get rid of the arrow. Cool. So I can draw a horizontal line through this graph at any point, and it's only ever going to cross one point on that graph. What that means is that this function does have an inverse, right? If I have, say, the graph of this quadratic, right? Here's a parabola, and I draw a line through it horizontally, right? Why don't you want to change colors for me? Right, I draw a line through this horizontally. This one crosses at 2 points. This function would not have an inverse. This function has an inverse.
Wait, but doesn't it, so it crossing through the graph means nothing? As long as it just crosses through that point of
If it crosses at 1 point, only 1 point, it means that it's got an inverse and we can go find what that inverse is. If it crosses at more than 1 point, it doesn't have an inverse. The problem is over. What's that?
The graph doesn't count as a point of entry.
A point of entry?
Like, you see where it connects to the graph right there?
It could be a straight line. It could be a straight line right here. I'm just showing that this graph, it only crosses at 1 point. I could be drawing a straight line here, right? This one crosses at 2 points, right? These are both functions, right? This is the graph of a function. This is a graph of a function. This is y equals x squared. This is y equals x cubed, right? These are both functions, but this function has an inverse. This one does not have an inverse. Does that make some sense? Makes sense to Moises. Does it make sense to? Yes, it makes sense to Anthony. Good. Summer, does it make sense to you? So that's how we're going to look at it graphically, right? I'm not even going to talk to you so much about one-to-one functions. Right now, what I want to talk to you now is about finding the inverse of functions algebraically. We talked about it informal before, but we need to know how to find it algebraically. And the good news is there's steps. Finding inverse functions algebraically. And we talked about it informally. And when we were talking about it informally, we said that it's kind of an undoing, right? We were looking at it and going, well, what has to be undone? And with the problems that we were doing, they were fairly simple. We're like, well, this is being done to X. We have to undo this to X. But when we get into more complex problems, we can't just look at it and see what that solution is, right? And so we're going to follow some steps. And the first step would be, well, sketch a graph, see if it even has one, right? I don't always have to sketch the graph. I could just mentally picture a graph. Like, I know what the graph of x cubed looks like, and I can look right at that knowing that a square looks like, and I can look at that knowing that I have an x squared, that it's going to be a parabola, and that's not going to have an inverse. And I can look at a cube and go, well, it's a cube, it's going to have an inverse, right? Because I can picture some of these in my head, but not all of them, right? Sketch a graph, see if it has an inverse. Like, kind of mentally sketch it. See if it passes the inverse test. See if it passes horizontal line test. Man, I do not like this new pen. I'm going to have to play with this a little bit and get good at it again. 2, rewrite it, right? Replace f of x with y. And we'll do an example so you don't have to just like kind of mentally do this. Then you're going to switch x and y. and solve for y. Or you're going to replace y with f inverse of x. Then last, you're going to verify. So you're going to have to now verify f of f inverse of x and f inverse of f of x. Basically what we're doing earlier this week. So clearly, I'm not just going to leave you to this, right? I'm going to take you through it. Let me give you a chance to get caught up on the writing of that for those of you that are taking notes. Summer, you with me? All right. 2 chances, all you get. She came back to me. She didn't answer me the last time I was ready to mark her absent, but she got a second chance. She's on it. She's back. That means I get to unmark her absent, right? So let's do a sample of this, and then you all will be free. Plus, we're almost out of time, right? So if I ask you to find the inverse of f of x equals 5 minus x over 3x plus 2. Now, I know that this is a fraction. I can look at it right now and tell you that it has an inverse, right? It's not a square, it's linear. It's going to have an inverse, right? There's no powers on any of these x's. So I can tell you right now, I don't have to do the sketch a graph part. I'm only telling you that because sketching a graph in this right now is a pain in the butt. And so I would like very much to skip that part. So I'm going to. And I'm going to tell you right now, without sketching the graph, that it does have an inverse. I know this because it's linear. It's going to give me a line. And so we are going to go to step 2. And step 2 is just replace f of x with y. So we are going to rewrite this as y equals 5 minus x over 3x plus 2, right? That's step 2. We skipped the graphing step. Why? Because I'm lazy and I only have so many minutes. The next step says switch x and y and solve for y. That means everywhere that I have an x in this, I'm going to put y. And everywhere I have a y in this, I'm going to put x. So right now I'm going to switch. I'm going to go x equals 5 minus y over 3y plus 2. And I'm going to solve this entire thing for y, right? We're going to solve for y. Oh no, what do? Y'all are in a panic, right? Yeah? No? I'm going to start by clearing this fraction. The way I'm going to do that is I'm going to multiply both sides. Why? Because I like doing stuff like that. I like getting rid of my fractions. So I'm going to multiply both sides by whatever my denominator is. And in this case, that is 3y plus 2. So here I'm going to multiply times 3y plus 2. Right? And if I distribute this, right, I wind up with 3xy plus 2x. right? Here, I am going to multiply 5. Oops, let's go. Let's do this. Let's do it up here. Y, so that I can save a little space. So here I've got 5 minus y times 3y plus 2. Well, that's just going to be 5 minus y, right? These cancel out. That's why we do it. What now? Well, I'm going to get all my y's on one side. Anything with a y on it, I'm going to have on one side. Anything without a y on it, I'm going to put on the other side. Right? So here, this doesn't have a y, so I'm just going to subtract 2x from both sides. And I get 3xy equals 5 minus y minus 2x. I want to get this y over to the other side. Why? Because I'm solving for y, and I want all my y's on one side. So I'm going to do that by adding y to both sides. So here I get 3xy plus y equals, let's put this in some kind of nice order. Let's go minus 2x minus y plus y is no y's. So plus 5. So now we've got it looking nice, right? It's in a pretty order. How do I go about solving this whole thing for y? Well, each of these have a y component, which means that I can factor a y out of them, right? So I could pull a y out of this and a y out of this piece because they each have at least one y. So here I'm going to factor out a y. If I factor a y out of 3xy, I'm left with 3x. If I factor a y out of y, I'm left with plus 1 because y divided by y equals 1 equals minus 2x plus 5. And we are almost there. We've almost solved this whole thing for y, right? Because the only thing that we've got going on now is we have that quantity of 3x plus 1 that's being multiplied to it. So I can divide both sides, right, by 3x plus 1. Why would I do that? Because it cancels it here. And I'm left with y equals minus 2x plus 5 over 3x plus 1. Is this ugly? A little bit. But if you understand fractions and how to deal with fractions, it's not so bad, right? So this is the inverse. The only thing we have left to do from our list of things to do is replace the y with f inverse of x and then verify these, right? So let's do that. So this means that this is just going to become, we're just going to replace y with f inverse of x equals minus 2x plus 5 over 3x plus 1, right? That is the inverse. What did we start with? We started with the function f of x equals, I don't remember what we started with. F of x equals 5 minus x over 3x plus 2, right? So how do we go about verifying that? Well, that's what we did earlier this week, right? When we verified, we plugged one into the other for x. And if we got x out, we knew it worked. Is that a pain? Heck yeah, it is. You guys know how to do it, right? So we've got our f of x, right? And so what are we going to do? Anywhere there is an x in here, we're going to plug in this whole thing, right? This inverse. So where do we have an f? We have 5 minus minus 2x plus 5. Will I get through this whole thing? Probably not. Over 3x plus 1 over 3 times minus 2x plus 5. I don't think any of your problems actually ask you to verify this. So if we don't get through the whole thing, it's not that big of a deal. And this whole thing is plus 2, right? And then you just have to see if you get an x out. We only have 2 minutes left. There's no way I'm going to finish this problem. But if you want me to, I will actually finish it in a separate little video. I'll just say like a practice problem video and finish the verification. It should not stop you from being able to do your homework. One, because we went over verifying inverse functions earlier this week, and two, because there shouldn't be any actually in the assignment to do, right? You don't have to do the actual verifying part. You just have to find the inverse in your homework. So let me stop this video for right now. Any questions before I